Now we'll apply this bend allowance calculation to our actual part that we're going to study. Here is a formed view at the top, and at the bottom is a flat pattern. And you notice that we are given the material thickness. In a real drawing, this would be in the bill of material, not on the drawing. And we're given the bend radius. So it's 3/8 thick, and it's a bend radius of 3/8. Our first step is to find the neutral axis. And this is mild steel, so the neutral axis will be 0.4 times the thickness from the inside bend to the neutral axis. So if your material is 0.375 thick, what is 0.375 times 0.4? That is the location, the distance to your bend radius. The location to your neutral axis. Now, let's figure out, when we're looking at this curved neutral axis, what is the radius of that imaginary circle? What is its radius? We have the bend radius from the press brake die, and we have our 0.4t calculation, so that will give us the distance from the center point to that neutral axis circle. Here is the bend radius, that is our press brake die. Here is our 0.4t. That will give us the radius of the neutral axis thing. Now let's find the circumference of this circle, that is the neutral axis. And remembering that the formula for circumference is 2 pi r, you just calculated how big r was, the r of this phantom line circle. So 2 pi r will give us a circumference. If you wanted to know this bend allowance at this corner here, you could divide the circumference by 1/4. You can actually skip this step, and I usually skip this step. Because what you really want to know is from where the straight segment ends to the middle of the bend, how long is that arc? And that arc is 1/8 of the circumference of that neutral axis circle. And when you punch the numbers in your calculator, I hope you come up with 0.412. I rounded this to 3 decimal places because that's what we usually do. It was actually not exactly 412. So that's the location of that bend line at the middle of that bend, from where the straight part ends to the middle of the bend. And remember that the bend line is always on the inside of the material, because that's where the press brake die goes. And the nice thing is, this is a uniform part. It's 3/8 thick all the way around, and it's got a 3/8 bend radius all the way around. So once you figure out that one distance, that 0.412, you know it's that same arc length at every corner. I've put those into my CAD sketch here. Now all you need to do is figure out how long are these straight segments, and that will allow you to figure out where is the location to the middle of each bend. So let's work through those. And our helpful hint is that our material is 3/8 thick in this part, and we have a 3/8 bend radius inside each corner. First, let's look at these legs at each end of the flat bar, and length 1 here is the same as length 5 because this is a symmetrical part. So we're looking for this straight length here from the end of the flat bar to where the straight part ends. First, let's find out how long this inside length is. And we did this before last time on our bend allowance warm-up thingy. But again, we have a 10-inch overall width, and this hat in the middle is a 6-inch width. So we have 10 inches minus 6 inches. That gives us 4 inches left over, and the 4 inches is divided between the right end and the left end. So 4 inches divided by 2 gives us 2 over here and 2 over here. Distance x here is 2 inches. Now, if that inside length is 2 inches, how do we get to the straight part? Well, the inside length is 2 inches, but we have a 3/8 radius, that's the curvy part, so this straight part must be 2 minus 3/8, that will give us x, and 2 minus 3/8 is 1 5/8. So now we can get to the first bend line. We have a straight part that's 1 5/8, and that curved section that's 412. 1 5/8 plus 412 is 2.037, just a tiny bit bigger than 2 1/32. And so on this end of the part it's 2.037, and on this end of the part it's 2.037. Now in your shop they are probably using tape measures that don't measure in thousandths, they measure in 30 seconds at best. So talk to your shop, they might want you to put 2.031 on each end because that's 2 1/32 of an inch. Ask them what they want. All right, now we want to get from that first bend line to the second bend line. So we want to find how long is this straight part in this vertical leg, dimension x. And what do we know? We have an overall height of 3 inches, and we're looking for just this straight segment. So 3 inches minus 3/8 material minus 3/8 bend radius, straight stuff, minus 3/8 bend radius minus another 3/8 material. We have 1 1/2 is the amount that we're left with. 3 minus 3/8 minus 3/8 minus 3/8 minus 3/8 leaves 1 1/2. Now let's locate our bend line. We have a 0.412 curvy stuff here, plus 1 1/2 straight stuff, plus another 0.412 curvy stuff. Those add up to 2.324. So we will put 2.324 in these two places too. Now, if it were me, I would not round any of these numbers to begin with. I would get all of the numbers in here exactly, so 2.037 on the end, 2.324, and whatever this turns out to be. And then we'll get to the very end, and then we can figure out, in consultation with our shop, where to go in and round off to a nearest 32nd. All right, now let's find the straight length inside this centerpiece. Thing number 3 here. So what do we have? We have a 6-inch overall width minus 3/8 material minus 3/8 bend radius coming over to the other end minus another 3/8 bend radius minus another 3/8 material. What have we got? 6 minus 3/8 3/8 3/8 3/8. We are left with a straight segment that is 4 1/2 inches long. And if you're locating your bend line, you have that 0.412 curvy part plus the 4 1/2 inch straight part plus another 412 curvy part. Those three numbers add up to 5.324. So that is the distance from the second bend line to the third bend line in the middle here. And I just want to point out something I think we haven't mentioned yet, which is that notice that I have written in the notes on the flat pattern, 2 of these bend lines are bend up. So the first one is bend up. When you're looking at the flat piece of flat bar, this leg is going to bend up, and this leg over here on the other end will bend up. When we say bend down, that means you can't just stick the flat bar in the press brake and go boom, 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 boom. You'll make a box. So you are telling them with this bend up and bend down note that these 2 bend lines in the middle of the part are bent the opposite direction from the 2 bend lines on the outside of the part. So here is a CAD layout with all these numbers strung together. The straight part, those 412 bends, the straight part, bends, so on and so forth. I've just strung them all the way around my drawing here. And then if you add up all these numbers, which I did at the bottom here, they add up to 14.049. That is precisely the overall length of the flat bar before you form it. Now, again, in consultation with your shop, you'll want to figure out, should you round that down to 14 1/32? Should you round up to the 64th? Probably not. Should you round up to 14 1/16 of an inch? That seems likely. I'd probably do that, but check with your shop and see what they would like. As you're doing this kind of calculation, as I have mentioned, it's really helpful to make a sketch. And your sketch is a tool for yourself, so it does not have to be attractive. Here's one that I made as I was working on this part. I was just thinking on paper, okay, what is happening? Here's where I'm trying to figure out the straight parts. Here's where I'm writing in the curvy parts. I made a diagonal line for where I think the bend lines will go. It's a good idea to do something like that for yourself. Now, you might be someone who likes to do this on paper, or you might be someone who likes to do this, backing up, on CAD, or you might do both. Either one will be good. As we've gone along, we have been figuring what you call chain dimensioning. We've been figuring from bend line to the next bend line, from that bend line to the next bend line. That's chain dimensioning. When you actually dimension your part for the shop, chain dimensioning is not preferable because you will get tolerance stack up, which we'll talk about some more later this term. So for actually dimensioning the part, you will want to convert all those lengths you found to baseline dimensioning, which I've shown at the bottom of this slide, all the lengths coming off the same baseline. That eliminates tolerance stack up, and it also does a favor to your press brake operator, who can just hook a tape measure at one end, stretch it out across the flat bar, and with a pencil go mark, 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 and be done. So that would be your finished drawing.